Welcome to Ask and Learn.
We're asked to show that the set of all strings, which are 0 to the 2n, 1 to the n, for n equals 0, 1, 2, and so on, is not regular using the pumping lemma given in a previous exercise, exercise 22. To do this, we'll use a proof by contradiction. So suppose that the set is regular. So we'll suppose that the set of all strings 0 to the 2n, 1 to the n equals 0, 1, and so on, is regular. Well, then it contains arbitrarily long strings. So the pumping lemma tells us that for some strings u, u and v, where v is not the empty string, and w the strings u, v to the I, w are in the set for each I. Now, suppose that v contains both zeros and ones. Well, then it follows that u v squared w cannot be in the set. Since uv squared w would have a 0 following a 1, which no string in our set has, right? Now, suppose that v contains only zeros. Then, for a large enough I, it's clear that u v to the I w contains more than twice as many zeros as ones. Again, meaning it wouldn't be in the set. Likewise, if we suppose that V contains only if we were to suppose that V contained only ones, then it would follow that we could find some I in the positive integers large enough such that u v to the iw would contain less than twice as many zeros as ones. And then, of course, u to the v to the iw would not be in the set again. But this is all the cases for what v can be, because remember, v cannot be the empty string. So this is a contradiction, and therefore it follows that the set is not regular.